All right. Hello, everybody, and welcome to the stream. I hope everybody is doing well tonight. Tonight, we're going to pick up where we left off last night, but just have a couple things to go over first. So before we jump into anything else, I do want to take a quick second just to thank the supporters of the channel, starting with the partners who are the highest tier of subscription over on Patreon and YouTube memberships. They are Gebi Bashir and Gerboles Inc. I would also like to thank all of the other supporters listed here on the screen. They are a combination of the other tiers of support over on Patreon and YouTube memberships, as well as Twitch subscriptions. So thank you all very much for your support. I greatly, greatly appreciate it. Of course, I appreciate all of the viewers, whether you're here on the Twitch side or over here on the YouTube side. We simulcast to both these days, so I appreciate each and every one of you who has followed along, and all of the newcomers as well. So welcome, and I appreciate you guys very much. Thank you for being here. All right, so first thing is actually Twitch just reminded me that today is actually my affiliate anniversary, which is interesting. So 1 year ago today, I became a Twitch affiliate, which meant that I had enough viewers and whatnot to be able to have, you know, bits and subs and all that stuff. So that's pretty cool. So just I figured that was kind of a neat thing that Twitch brought up, right? So there's that. And then let's see. Taman, hello, welcome. You are here early tonight, actually. Awesome. Good to see you here. Nilsson, yeah, you think you're too early? Yeah, no, no, you're good actually. We are starting a little bit early tonight. But yeah, welcome. Good evening, Doc Lock. Good to see you. How are you doing? Welcome to the stream. All right, so just to kind of recap what we were doing yesterday. We were working on sort of taking all of our render graph logic that we'd sort of built out in our testbed, and we're kind of splitting those into multiple render graphs. And the reason for that is because we want to have some sort of pre-configured options available for people that want to use the engine so that you don't have to actually set this up in the application every single time. All the application should ultimately have to do is kind of say which one of these render graphs it wants to use and then what order to use them in, and so forth. If you want to configure one manually, you can do that, but you shouldn't be forced to, right? So that's kind of the idea here. So last night we got the forward rendering render graph set up. And so I think that one's completely done. And then off camera, I spent a little bit of time doing the one for the editor, which there wasn't too much for that. So that's the editor render graph here. And the editor render graph is actually part of the testbed right now because we don't have an editor application. So for right now, it exists in graphs right there, along with the passes here. So when we actually create our editor application, these will be moving out of here into that application, along with this editor gizmo, right? So that's where they live for now. They'll be moved in the short future. So the last one we really have to figure out tonight is the UI. And that's basically going to be grouped in with the standard UI. And then basically we'll wind up using these 3 different render graphs in sequence, right? So it'll more or less accomplish the same thing, but our code will kind of be split up a little bit better. Let's see, Taman, it's nice to see how your channel is growing. Very soon you will need to use a smaller font on the supporters list. Yeah, I was thinking that actually, which is kind of cool, and you know I appreciate it a lot for sure. It definitely is neat to see it grow, and neat to see that folks are appreciating the work that I'm putting into it because it's a lot, right? But I love it, right? So there is that. All right, so what I'm going to do for this last render graph that we have to set up is I'm actually going to kind of use this editor render graph as a little bit of a template. because this one is pretty close to what we're going to have to do for the standard UI one, right? And the standard UI one's actually, I think, it might wind up being a little bit simpler than this even. But what we're going to do is we're actually going to create this one in the standard UI library. So we already have our passes that exist there, which is the UI pass, right? We should probably rename that to standard UI pass, I suppose, but I'll leave that alone for now. So we'll do graphs, and then in graphs we will do. Let's see, what do we want to call this? I guess render graph standard UI. I think that works. So we'll do a header file, and then we'll also do a render graph standard UI C file. Okay, and then what I'm going to do is I'm actually just going to grab everything in this editor render graph C file and open up render graph standard UI C and paste this in here. And we'll just do a find and replace. So it's going to be editor render graph, and I'm just including all of that to make sure that I don't miss anything. And we'll call this, is my naming backwards? I guess we'll say standard UI render graph. Yeah, I think I named my C files backwards. That's fine. We'll fix that in a second. So just have to run this a few times. Okay. Basically until there's not anything left. All right. So let's write this. And then we'll do this. Harold Ruth, thank you for the follow. Welcome. Hope you're doing all right. Cry over on the YouTube side. Hello, welcome to the stream. Good to see you. All right, so let's just quickly remove, or rename these files rather. So I'm going to do, I'm not sure how I got that backwards in my head, but so we'll say standard UI render graph, and we'll do the same thing here. Oh, wait a minute, I already renamed that one. This is the one I want to rename. Right, so we'll do that and kill that. Okay, so the other thing that I want to do is I'll go to editor render graph H, and I'm actually going to do the same thing. So grab all of this, standard UI render graph H, paste that, right? And then we'll do a find and replace again. A couple of times. Okay. All right. So that's more or less the way we need it set up. We're also going to rename this to UI pass. We don't need the editor gizmo. That was something that the editor itself just needed. We don't need that. And we'll see what else we actually need, right? We actually don't need this additional function down here either. So the editor needed that. We don't need it. Okay. So we don't need editor gizmo. Get rid of that. We'll go down to the bottom. We'll get rid of this here. Okay. So I want to move this to the top. And this should be standard UI render graph. Okay. And then this will be UI pass instead of editor pass. Standard UI render graph, that's fine. Okay, so we need these global sources still. And then we can go over to testbed main, and we need actually this UI configuration. So we need this. So we're just going to overwrite that. This is UI pass. And then that means that we can get rid of this stuff. And actually we can just take this, put this here. Standard UI, render graph initialize. We need to include that. So we'll do. Do we actually have graphs? Do we not actually include that here? UI rendergraph.h. Okay, we might actually have to fix that. Thank you for the happy affiliate anniversary. I appreciate that. Sleepy Mushroom, it's good to see you. Welcome to the stream. Hope you're doing well. So we are basically moving the last of our UI render graph code. And then once we get this working, we're actually going to start talking about something a little different that we kind of need to figure out in terms of loading performance. Let me just see something real quick. Okay. So here we have all of these states that need to be replaced with outgraph. So we'll just do that real quick. Okay, and this one here as well. And obviously that member is wrong, so we'll need to fix that as well. So it's not called frame graph, it's called internal graph. So we'll need to fix that. Okay, so that should be all we need to do there. And then, let's see, why isn't this? Oh, because it's under controls. How did that happen? That should be under source. Right. That would explain why this file over here couldn't find it. Okay, so over here. Is it still wrong? So it's under source and then graphs. Standard UI rendergraph.h. Why is it saying that doesn't exist? File not found. but yet when I type it back in, it works. Help me understand that. Okay. Also, we don't need any of these passes here anymore because these are actually handled by the individual render graphs. So we don't need those. And actually, we should probably move. These other graphs here. We've got this one. And this one. Which I suppose we could just use quotes, right? That's fine. Okay. So that's that. Core shadow map pass. I don't think we don't actually need this one either. That's part of this pass. Okay. So the only one that's part of core is the forward render graph. And then these two are extensions, essentially. Potham7787, hello. Hope you're doing well tonight. Doing pretty well over here. Can't complain. Just working through the rest of the changes that we kind of started last night. And then we're going to move on to some loading performance stuff. Because there's some stuff I've been wanting to get to for a while that we haven't really gotten to. And it's annoying me. So we need to start thinking about, clamping some of this stuff down before we actually, add more features, right? Do a performance pass, do a cleanup pass, that kind of stuff. Start buttoning down some of the code, right? Diamond, hello. Thank you for the happy affiliate anniversary wishes. I appreciate that. Can't believe it's already been a year since it's actually been only just over a year since I started streaming on Twitch. Which is crazy to actually think it's already been a year. But also it doesn't feel like it's been a year. I'm going to remove this old view stuff. That's gone. We don't need that anymore. Some of this editor temp stuff I'm going to move around too. Let's see. Been good. Just more OpenGL using CPP, but besides that, can't complain. Yeah. I mean, OpenGL's not that bad, right? Could be worse. You could be writing Objective-C. Could always be worse. All right. So we don't need to worry about hot reloading for this. I had that in there as the editor note because because the editor doesn't really exist yet and we have that in the test bed, if we hot reload the test bed, that's going to break that pass. So that's why I put that there. We'll have to address that. All right. So outgraph UI pass. Oops, pass. We're going to need the function pointers from here. I think it was PFNs. Okay, so we already moved these. Those are gone. These are what I need to move. So actually, I'm gonna put them here. Outgraph. Okay, get rid of these guys. Don't need those. All right. So that's our function pointers. Then we finalize just like we have elsewhere. So that means over here on this side, we can actually get rid of this refresh PFNs, I think. You know what? I'm actually going to do the hot reloading stuff now for the editor render pass, or the editor render graph rather. So in this case, it's going to be return type void, editor render graph refresh PFNs. And I think all we're actually going to need is this. All right, let me clear these highlights because they're kind of annoying. And let me go back to the C file. All right, so essentially what we're going to do I did this in the standard UI function. That's not where I wanted it. I wanted it in the editor. Bottom of this file. Helps to paste it in the right file. Okay. So when we go to set this up, right here, this is the hot reloading. So we're going to put this here. And these will get changed to just graph. Right, and we're basically just going to reset those function pointers. Right, so instead of doing this here, we could just call the refresh function as well. So we'll do editor, render graph, refresh PFNs, and then we'll do out graph here as the pointer to that. And then we don't have that to do anymore. We don't have to worry about that. Right? And then over here in testbed, where we have this refresh render graph PFNs, the only one that we actually will have to do that for now is going to be editor, render graph, refresh PFNs, and we're going to do state editor graph. Want the address of that, right? And then we can get rid of these. So that just makes sure that whenever we hot reload the library, that gets passed down through, and it does the thing it needs to do. Let's see. I've never done anything on the Mac, so I don't know about Objective-C besides what I've heard on the internet. Yeah, its syntax is kind of the thing that I don't really like about it, right? It's a love or hate thing. You're usually on one side of the fence or other. So this file here in the repo is actually mixed C and Objective-C. So if you're wondering what Objective-C looks like, have a look at this guy, right? Now obviously this is if def'd out, so I don't have the the syntax highlighting, but like, yeah. If you're wondering what that looks like, it's in there. Because in order to actually access the windowing APIs and stuff like that, you have to use Objective-C. And I believe the same is going to be true when we go to add the iOS platform layer. So that's going to be fun. All right. So the editor render graph still has some things we need to solve, but I want to finish up this one first. So all this stuff in prepare frame can go, including the check to see if the simple scene is loaded, because the UI doesn't care anything about scenes. So if we go to, let's see, did we already get our initialize here? standard UI. This needs to be standard UI graph. I don't think we've created that yet, so we should probably go into our game state and create that. Standard UI render graph. Standard UI graph. All right, so we have that. This is going to be standard UI render graph failed to initialize. Okay. Whoops. Did I? Yeah, I just did the wrong one. Let's move this down here. Move this one up here. Okay. So we do the forward render graph, the editor render graph, and then the standard UI render graph. Why is this bleating? It should be there, isn't it? Oh, it would be there if I spelled standard correctly. There we go. Okay, so our configure render graphs is set up. Refresh render graph PFNs, I don't need to call here, because that's automatically called by the render graphs that need it. So that should be fine. We also don't need to finalize here, because that is taken care of for us by the individual render graphs. We're under 1,100 lines of code in our testbed main, which is down about 1,000 lines, if you recall. So let's see. What's the next thing we need to do? We probably need to move the... See, I don't think we had anything in here for resize. Oh, yeah, we did. We need to put that hook in here. So this is going to be standard UI render graph on resize. Standard UI graph. Okay. So we got that render frame. Okay. So this is also going to be something that we're going to need to do. I'm actually going to take a copy of the one for the editor and just replace this guy with that, and then rename to standard UI render graph execute standard UI graph, and then standard UI render graph catch the failure. All right, so there's that. Here's the prepare frame. So this is going to be, I think, one of the last things that we actually have to set up. So we want to go ahead and take a copy of that and just change this over to do the standard UI stuff. Yep, that should be good. We're going to have ads here in a second, FYI. Standard UI render graph. Catch the error there. I also forgot to rename this. Okay, so that's that. And then the actual UI logic is here, right? Not very much. So in the frame prepare, right there, that is essentially all we need to do for this one. So it's much simpler than our other ones, at least for now. So we'll do graph UI pass. Okay. So the viewport is going to be current viewport, and it's going to be current viewport projection for this one. We don't have a view matrix for that one. In fact, we should probably adjust that to like not even have a view matrix for the UI, because it kind of doesn't make any sense. Okay, SUI state is systems manager get state. So we are going to have to address that as well. We are going to have ads here in just a second. From Lake, good to see you over on the YouTube side. How are you doing tonight? Welcome, welcome. All right. So what this does is it basically gets our standard UI state and performs the render call against that state. We have ads. So for those of you who are new to the channel, on Twitch, we are given, or we are served ads once every 30 minutes for 90 seconds. There's no way around it, really. I do that to prevent pre-roll ads. And so depending on your region / locale and what platform you're on, you may or may not get ads at all. You might only get 30 seconds of ads, or you might get 90 seconds of ads. So I try to just account for that. Now, I know over on the YouTube side, ads work a little bit differently over there. So, you know, I just try to account for sort of the worst case scenario on both sides, being that 90 seconds. So it gives us a chance to break, stretch for a second. And in my case, I like to hydrate on every ad break so I don't forget to do it. And if you guys are not hydrating, you probably should be as well. So take these ad breaks as an opportunity to get some water, right? All right, so that being said, we've got a little over 10 seconds left on our ad break, and we'll be back to it, if I can speak tonight. All right. And ads are dead. Cool. So, let's see. So what we're going to do is we are going to need the systems manager here in order to obtain the state. So I'm going to do include, was that under core? Yeah, it is. Core systems manager. All right. So that way we can make this call. And then, yeah, we use the standard UI system type there. So that goes ahead and gets the states, passes that through to the standard UI system, gathers all the render data, does the things that we need it to do, and then we go ahead and we execute the frame. Shouldn't be anything there we need to do either. All right, so I'm just going to actually say prepare the configured render graphs. Okay, we can get rid of this to do. That's kind of not necessary at this point. So our prepare frame is like just this now, right? And all the complexity is moved off to these individual render graphs. Okay, so we have that. Let me think what else there is. We still have a lot of like this stuff that's happening in application update, but I think most of this is fine because it's fairly specific to the test bed application. So I think I'm okay with most of that. Let me see. Is there anything else in here that we needed to move? I don't think so. Render graph load resources. Okay. Yeah, this is actually something. So did we actually set this up in order to... This is where we load all of our controls. But before we do that, okay, so initially where we had one render graph, we were calling load resources here. This is technically where we should probably be calling our render graph initialize, right? Which calls load resources under the head for the internal graph. So we should probably be calling that for all three here. We didn't actually do that at all. So I'm going to replace this with, let's do the forward render graph initialize here. And then this is going to be the state forward graph. And we'll say forward render graph resources for the error. Oops, I want the next line up. All right, so we can take this and we'll do the editor render graph, editor graph, standard UI graph, standard UI render graph. There we go. Okay, so standard UI and then editor, all right? So eventually, basically all that'll change is when we create our editor application, this will essentially move where this function lives will move, but like the calls to it won't move. Okay. I think we should be good as far as this is concerned. We don't have any more errors in the testbed main. We don't have any errors in the standard UI render graph. And I don't think we have any in the forward render graph either. Nope. So the one we have to figure out is the editor render graph, because we do have some problems with this that we need to fix. Namely, or did we already fix them? I thought it was here. Maybe it was the forward render that had it. Maybe I commented it out. It's possible. Let's see. Yes. So this was one thing that I kind of just got thinking about while I was laying in bed trying to sleep last night. So we have all of this sort of debug geometry that we kind of include in the scene right now that I'm thinking probably doesn't make sense for it to actually live there. I'm thinking all of that debug geometry probably belongs in the editor layer. And the reason I'm thinking that is because our scene probably shouldn't be caring about that kind of thing. The only difference or the only drawback to moving it to the editor layer is it's going to cause all of our geometry, all our debug geometry to sort of draw on top of everything else. But I don't know that that's a huge issue. So, because we probably shouldn't be drawing bounding boxes on everything all the time anyways, right? We should have toggles for those things, or maybe like only the selected one actually draws its bounding box, that kind of thing. Just to make the scene a little bit less confusing to look at, right? So I think we're going to wind up making some changes in how our debug geometry is actually written, or drawn rather. But let's go ahead and build this real quick and see what errors we get, because we weren't actually able to do that last night. Okay. Testbed types not found in simplescene.c. Why do we need testbed types in simple scene? Not sure we do. That might have been a leftover from when I was like moving stuff around. What is going on here? Okay, that might be a leftover from when I was like moving things around. Actually, the next thing we should probably do is like rename simple scene because we've been talking about doing that forever. So if this works as is, I'm probably just going to commit the changes and then rename simple scene. Let's see. Unused function, refresh render graph PFNs. Unused. Really? Lib on load, I thought was calling this. Okay. This is probably... This is probably where that should live. Okay, so refresh render graph PFNs game inst, which I think is what that wants. Or did it want the application? I forget. Wait. Refresh render graph PFNs. Oh, this is defined later in the file, and I'll bet it's not forward declared. It is not. That's why it can't find it. All right, let's see if this runs or if it just dies hideously. Yeah, it dies hideously. That's cool. All right, render graph load resources. What do we have going on here? Well, we probably didn't call render graph create. I don't actually remember putting that in. We probably never did. So that's going to be in our testbed as well. That's probably going to be in... It's going to be application boot, maybe? Or initialize. Probably application boot. Configure render graphs. Yeah, here it is. All right, so if I go to configure render graphs. Oh, wait a minute, though. I did the thing. Still didn't fix this typo. So that should have worked. Let me make sure in the console log we didn't get any errors that we weren't expecting. Booting testbed. Nope, I don't see anything. So for some reason it didn't even get that far. Okay. So let's run this again. Render graph load resources. So we're calling render graph initialize. Oh. Oh, I see what we did. We're calling initialize here instead of create. We should be calling create first. And then these initialize calls should actually be happening in application initialize. Yeah, so we've just mixed up our order of operations there. Okay. So let's rename this to create render graphs. Right, and then here we'll do create, and create, right? And this does take configuration for each one of these things too, I believe. Yeah. So it takes the config and then it takes the graph. All right, so forward render graph config, forward config. Right, we'll start off by zeroing that off and zeroing that out, and then say forward config shadow map resolution equals 2048. And then we can pass the address of forward config for that. So that resolves that one. Editor render graph creates. So this one is going to be editor render graph config, editor config. Again, we'll zero that out. Editor config dummy equals 0, right? We put that there just to be clear because we needed some sort of structure here. And we're eventually are going to have configuration properties for the editor render graph, but we don't have any right now. But I still wanted to sort of type def the structure and have this ready to go so that when we need to do this, we don't have to like reconfigure it and set up all the types and stuff like that. So what I did is I just put a single property in there as a dummy so that we don't have to bother with that later. We don't have to change this code down the road for that. All right, so we have the address of editor config. Whoops, config. All right, so that's that one. And then let me just move this up a bit. And standard UI render graph config. SUI config equals 0. SUI config, again, dummy field equals 0, right? And again, we don't have any properties for this yet, but we eventually will. Okay, so that's the create. We need to go into the application initialize, right, which is post boot. Oh, look at that. We have the initialize calls here too. So I think what I'm actually going to do, I'm going to clip these. Actually, no, I'm not. Not yet. Let me go here. Because we have this create render graphs. I'm going to do jeez. Hit the right keys, you dingus. Let's try this again. Initialize render graphs. And let's actually just, right, we'll do prepare render graphs. And we'll do execute render graphs, right? So that way we have just kind of these things all grouped together, right? So we have create render graphs is here, and then we'll do the other definitions here. I don't know that these actually need to be booleans, but I suppose that's fine. Okay, so we'll do application initialize, take all of this and replace it with a call to initialize render graphs passing the game inst. Right? And if we go to definition on this guy, paste this here, go to the end, return true. Right? We don't have the state, but we do have that here. So that's just a cold cast, no big deal there. All right. And this just kind of allows me to put like all of the render graph stuff like right next to each other. So application prepare frame. It's going to do the same thing. So in this case, it's going to be prepare render graphs app inst. We've got some naming inconsistencies with that I probably need to fix. Right. Put this here. Turn true. Grab the states. Oh, this one needs p-frame data as well. So, frame data, p-frame data. We'll do, do that. This is also going to need to be done. Why did it? I didn't want the whole line. Dang it. Okay, fine. Why is it selecting the whole line? Stop it. Oh, I had caps lock on. That would do it. Okay, so let's do that. Okay. So we have prepare render graphs, execute render graphs. Both of those guys require frame data. All right, so execute render graphs is going to need to be in right here, render frame. So here we have execute render graphs. In this case, is going to be the game instance and the p-frame data. We'll get to that in just a second. I just want to paste this in real quick. That's all right. And then this is just going to pass through p-frame data. All right. Now, all of these things pass, or I should say return booleans. So we need to actually add some checks in here to make sure that this stuff actually succeeds. So right. Execution of, whoops, of render graphs failed. See logs for details. Return false, right? And I'm actually going to take these lines, move them up here. Why did you only copy? So we need this, and then prepare render graphs is going to be if not prepare render graphs. Then we do that. Okay. So we've got that. Application initialize. Check this one for failure. Failed to initialize render graphs. See logs for details. Turn false. All right, cool. Sober Dubois, I think that's how you pronounce that. Thank you for the follow. Appreciate that. Welcome to the stream. Singy, hello. Good to see you. Welcome. Hope you're doing well tonight. All right, so we have initialized render graphs. What was the last one? Create render graphs. Okay, this one actually already kind of existed. Just didn't have a message there. All right, so let's build this thing and see where this lands us. Undeclared identifier p frame data. Oh. I'll bet I didn't add those to the forward declarations, did I? Oh yeah, I did. Oh, I didn't add it here though. Frame data, p frame data. Okay, built successfully. Let's see how hard it crashes this time. All right, we got a little further. Oh, I bet I know what the problem is. Okay. Yeah, it's going to be the sync linkage. So we just kind of blindly copy pasted this stuff. And we can't really do that, right? Because we had this sort of dependency set up between these render graph passes. And now it's bleating that it can't actually find that, which makes sense because we split them up. So, let's see. We were setting up the editor. And we were putting into the color buffer from the scene color buffer. And what we really want is the global one. So if we go to editor, I'm actually just going to close this other view here for a second. And we're going to have ads here in just a second, FYI. Let's see. So we need this from the, instead of the scene, we want the global one. So what we really need to do is just kill that. Right, so 0/null there means pull it globally. I think this is going to be a problem for our UI pass too, but I just want to run this to make sure we eliminated that error. Okay, unable to find source path name editor for UI. Yep, okay, so it's the same problem. Okay, cool. So we resolved the last one. Standard UI render graph. So we do the sync linkage here. Instead of using the editor color buffer, we want to use the global one. Woozex, thank you for the affiliate anniversary wishes. Appreciate that. Thank you. Okay, so we've built that. And now we have ads. So you guys will have to wait to see the result. In terms of what we're doing here, we pause the stream whenever we are served ads on Twitch, which is once every 30 minutes, we get 90 seconds of ads, right? So I would recommend taking this time to hydrate. That's what I'm going to do. That way, you guys don't miss any content, right? All right. So we've got about 50 seconds left. So yeah, we'll continue after that. I do see the questions over there on the YouTube side. Speaking of which, the YouTube side, I know you guys don't get ads the same way that Twitch does, but you know, we just pause across the board so that way nobody misses any content, right? So we just like to do that out of respect to the viewers. Okay. Almost all the way through ads. Grab some more water. All right. Ads are dead. Cool. All right, so question over on the YouTube side. Are you programmatically inserting pipeline barriers to manage dependencies between render passes, or how do you make sure everything is synced properly? Yeah, so we use subpass dependencies and is basically how we manage that right now. More or less, right? So I would imagine at some point when we get ready to do things that are a little bit more advanced, I'm going to have to come up with something a little bit more robust than that. I'm kind of getting away with that for now, but eventually when we start firing off parts of the rendering process to different threads, I'm going to need a better way to synchronize that. So, but we're not there yet. Things were so much simpler before barriers. Yeah, 100%. Yeah, that can be kind of annoying sometimes, right? So, more than likely, probably what I'm going to wind up doing is having some sort of semaphore/fence setup where I can manage our render pass dependencies that way, sort of through our front end instead of doing it, you know, the Vulkan way and sort of relying on that, right? Because we don't want to have we don't want to have the front end acting different ways for different back ends, essentially. State tracking is a pain, and I will never understand the decisions they made, both in Vulkan and DirectX 12. So they made those decisions to give the application developer ultimate power and control over how that works, right? And that's very similar to the way the actual hardware works. So they were trying to be very close to the metal on that one, essentially. And that's the reason they kind of went that way, right? OpenGL just kind of always abstracted that away. So people are annoyed about it, but like OpenGL was just kind of doing that for you, but you had no control over how it did it. So if it didn't do it in the most optimal way, you had to kind of work around that, right? Why can't they track the current state? Because state is up to the application, right? What state are you talking about specifically? Let's see. Over on the other side, how do you deal with constant possible failures, errors? I can get very anxious sometimes at the fear and dread of constant failures when compiling. Truthfully, it just comes from years of doing it. Honestly, you get used to what the error messages mean. And if you don't know what the error message means, Google it. right? More often than not, you can get an idea of what it means there. But honestly, more often than not, too, if you really sit down and think about what you're reading in the error message will kind of give you hints as to what the problem is, right? So it really comes down to breaking down what the error message is telling you, knowing how to research that, and then experience over time, more or less. Yeah, after years it becomes less of a big deal. Exactly. Yeah, Jammed Lock, thank you for the follow. You don't see as many errors you've never seen. Yeah, so that's the thing. Like, all the errors that I get when I'm compiling, I'm like, oh, I know it's this. Oh, I know it's this. Very, very seldom do I have to look it up anymore because it's all stuff I've seen before. It's usually just, all of the most of the common errors of the program are being stupid, right? And, when the compiler's slapping you for doing something stupid, you get used to being, the type of slap. You get used to it, right? Why do I have to keep track of what state the resource is in? Because if you use the wrong state in the validation layer, will tell you it's wrong and what the current state is. Yes, but remember, the validation layer is just that. It is a validation layer. When you ship production code, you shouldn't be shipping it with the validation layers turned on, right? So the validation layer is there as a tool to help you say, hey, this is what you're doing. You shouldn't be doing that, right? So that you can fix your application code so that it doesn't do that wrong thing. But the validation layer isn't there afterwards, right? It's not part of core Vulkan, right? Vulkan was designed to be very lightweight, very thin, for speed. So if it was doing a bunch of state tracking and overhead like that, it wouldn't be as thin as it is, more or less. I doubt this additional information current state would make the driver less perform to be honest. I doubt that. I mean, the whole thing is you have to know what you're doing, right? And that's where the complication comes in. OpenGL masks a lot of that stuff away from you, sure. And yes, it handles a lot of that state for you, but it'll also give you a lot of really weird nondescript errors too. Yeah, exactly. So, as Strange Zach says, that's why they moved off of OpenGL and Direct3D 11 models, right? Because they used to do all that. It does actually make a difference. It really does. You're not typically going to see it in a simple renderer, right? But where you're really going to see that stuff add up is in very complex renderers, AAA renderers and stuff like that. You're very much of the mindset just to use those APIs as they are way simpler. I mean, I used to think that, but I also feel like since I've been working with Vulkan, I have so much of a better understanding of how all this stuff works under the hood that, again, it's just like the compiler errors, right? Like, after you've seen that stuff enough times, you kind of get used to it, right? And then it just doesn't bother you as much because you're just like, oh, well, that was stupid because I'm doing this out of order or something like that, right? Speaking of doing things out of order, I'm not quite sure. Yeah, we were basically getting a blank screen there, so something's obviously foobar. You agree with explicitly transitioning resources? You talking about like resource layout and stuff like that, like image layout? Yeah, I agree with that too, and also the whole using different buffers for device local memory versus host visible memory and all that. Like, that's a big deal too. All right, so let's see. Let me rerun this. Okay. So what we're getting here is just a blank screen. Did we get any errors? I don't think we did. It set up all of our render targets correctly. And that's just a warning for something not being used. Okay. So we're not getting any explicit errors, but we're also not sort of drawing anything here to the screen. So I think, let me take a look really fast. Oh, what's this about? RenderPass UI. Oh, okay. The device is shutting down before we shut down the RenderPass. That's because we didn't actually destroy our RenderPasses anyway, or our render graphs. So I'm not worried about that. I can fix that in a separate pass. That's not a big deal. All right, let me think here. So we have this global source add. Let me think. So this is source origin global. Oh, this is probably, these are probably wrong. Let's see. So we have a source. Actually, I don't think these matter. Let's try changing it, though. We'll do global on these, right? So that's standard UI. Let me try changing it on this one. I don't think we've got everything here hooked up correctly yet. Because basically the way it was working is we were sort of passing the same resource down from render pass to render pass. Back buffer global sync because no source was found. Okay. So let's just keep this here for a second. I want to look at the forward render graph and see if we can figure out what's going on. Cat Me, thank you for the follow. Welcome. First time chat also. Any advice on learning first programming language, learning Python now? So if Python is sort of what you're learning, stick with that for a bit, right? Get comfortable with that and understand the concepts, right? There is no wrong first language. Mostly what it's going to be is decide what you want to do with programming, right? Decide what you want to make. Do a little bit of research as to languages that are used for that thing. In terms of games, you might want to look into different game engines and what languages they use. But if you're just learning the ropes of programming to start out, whatever language you picked is fine. Because a lot of those skills, the basics of it will translate to another language, right? The things that'll change is like syntax rules of the language and stuff like that. But the basic concepts like branching and recursion and that kind of thing will all translate, right? Make a program that solves a real problem. Exactly, Taman. Yeah. You're in college for game programming and development, and for the intro classes, you're learning Python and Java. You start in 7 months on those classes, you want to get ahead, so I'm trying to learn Python on my own. That's not a bad idea, right? I do question why they're going to have you use Python and Java in a game programming course. Because the most common languages for that are like C, C++, C#, for like Unity and stuff like that. But if that's what they're going to use, yeah, industry standard languages, exactly. If that's what they're going to use for that, it's not a bad idea to study that, right? I will say this though, if you learn Java, you're like 80% the way of learning C# as well. So a lot of that stuff will translate to other languages as well. So they're a little bit weird language choices for a game development curriculum, I would think, but maybe they have their reasons for choosing that, right? So like I said, there is no wrong language. Just do a little bit of reading. Follow a tutorial when you get stuck, but don't get in a tutorial loop, right? Try to figure the things out on your own. Understand what error messages mean, and just write lots of code and don't be afraid to throw it out, right? That kind of thing. Yeah. Also going to learn C++, C#, and some other ones. Exactly. Yep. Those are the ones you're going to want to eventually learn. But, start simple. If you haven't really programmed before, starting with Python is fine, but you're going to want to eventually move on to C# or C++, or even C, right? Plus Unreal Engine blueprints. Yeah, so Unreal uses C++. Let's see. Strange Zach, you're also a DirectX guy. You've never used Vulkan. Yeah, so I used DirectX 9 back in the day. I did a little bit of stuff in 10, and briefly touched 11. I haven't used 12 yet, but 12 is what we're going to wind up using for this engine when I get there. So that should be interesting. Blueprints are kind of outdated. Are they? I'll be honest, I haven't actually tried making a game in Unreal Engine 5. It doesn't use it anymore. Interesting. Okay. So what do they use? Just straight up C++ now? Let's see. How long have I been programming for? I've been programming since I was 7. So, oh god. 30. What am I going to be this year? Okay, so right now 31 years, essentially. They're still in UE5. It just... Oh, okay. Yeah, I was going to say, I can't imagine them getting rid of blueprints. That's been like their thing. Jake Robert, thank you for the follow and welcome. All right. First time chat, welcome. Nice to see a little C work. Yeah, exactly. Yeah, I love C. This is my favorite language for sure. So yes, it's good to have another C dev here. Welcome. All right, so let's do. Let's see. When we create our scene or a forward render graph, we do origin global on that one, origin global on that one. Source origin other. Oh, so it has to be other because... Oh, right. Okay. So this change was wrong. Let me back that out. This one should be correct, though. So when we set the sync linkage, it should be just like what this guy is doing here. So we should say, okay, for the internal graph, for the skybox pass, color buffer attachment, we want the source pass to be 0, which is global. And we want to use the color buffer source for this sync, right? So it links those two together. So we should be doing the same thing over here, where we take the color buffer and the depth buffer, from global. And these are both source origin global, which means they should be pulling the swap chain images and the device depth image respectively. Let's see. Is it bad that looking at code is actually intimidating? No, not at all. Take it as a challenge, right? I mean, I've been doing this for, as we just discussed, 30 plus years, and I still find stuff challenging, right? And when I look at something I don't understand, I take that as a challenge. And then I go off and do my best to understand that thing, right? So if you look at it like that, you'll never run into that problem. It's bad if it stops you from learning or makes you lose interest. Yes, I would agree with that. Yeah, exactly. As Taman says in chat, Taman gets motivated into learning even more. That's kind of the way it is for me. It's a perspective thing, right? LQD, yeah. Yeah, I did tell my age, but I mean, I'm going to be 39 this year, so gross. I hate getting old. It sucks. Oh, well, what are you going to do? I suppose getting old is better than not being around to get old, right? That's how we got to look at it. All right, so why is this not drawing as I expect? We may have to crank up render doc to see. So we can see that we're clearing the screen, but we're not getting like any of our text being drawn or anything. And when I try to actually load a scene, we're not getting that either. So I guess let me determine why that is. Move this up a little bit. Move this up a little bit. Okay, so we're in our editor render graph frame prepare. Oh, I think I know what the problem is here. Womp womp. We didn't assign our gizmo. You know, I was thinking about that earlier, and I completely forgot about it. So let me fix that real quick. So that's going to have to be in testbed main. Let's see. Where do we create the gizmo? Gizmo create. Here we go. So we do create, initialize, load. So I think right here, we'll do editor, render graph, gizmo set. And for the graph, it's going to be the address of state editor graph. And then we're going to pass through the address of state gizmo. Do we do a boolean here? I forget. No. Okay. So that's kind of important to be set, because the editor render graph doesn't own the gizmo, but it needs to know about it. Ultimately, our editor will own that and know to set it, right? But since we don't have an editor yet and we're kind of doing all this stuff in line, this is where we have to put it. All right, so let's load this up again. And we will load a scene. Okay, so that's interesting. So the scene loads and draws with all of our passes, right? We see our skybox passes working. The scene seems to work, and the editor pass works. And I know the editor pass works because we see our gizmo here, right? And it even interacts with the objects as it should, right? So that's interesting. Let me think about that for a second. So two of our render graphs are working. The last one is not. Interesting. And yes, I know this is because we're not destroying it properly. We'll fix that afterwards. Let's see. Almost 40s, yeah, I know. You're almost at your 30s. You want to trade? You want to trade, Taman? I'll trade you. If you could figure out how to do it. Surely we can write some code to do that, right? My birthday is in September. You turned 21 this year. That's awesome. I could say that I, remember when I turned 21, but I don't want to sound like a boomer, right? I mean, I do, but I didn't get that blasted. All right. So I'm thinking... I wonder if this is a data gathering issue. So when we do prepare render graphs, we are doing the standard UI frame prepare, passing in all the good stuff. Let me just check our execute real quick. We are doing that as well. So our execute's here. So I'm wondering if it's a problem with the pass itself. So I don't think it's like the sync linkage or any of that stuff, actually. Because if it was, we would be getting flat-out errors on this stuff not working correctly. UI pass initialize. So we load resources there, we do update here, we do frame prepare here. And then we execute the frame for that here. I'm not seeing anything that looks off. May actually have to step through this. You don't drink or anything like that? Yeah, that's probably not a bad thing, right? You might have some just for the hell of it when it's your birthday. Yeah, exactly. Have a beer or something and enjoy it, right? But no need to get blasted. LQD, you turned 24 last month. Nice. Y'all are young'uns. Making me feel old. I guess it is what it is, right? We all wind up there eventually. Hopefully. Do you know how to implement Unreal Engine features such as Lumen, Nanite, World Partition, etc.? So we're probably going to experiment with some of that stuff. Mind you, those were features that were written by teams of people. I'm one dude. So we're not going to go crazy with that stuff because a lot of those features would take weeks, if not months or years to write by yourself, right? And so, we're going to mess around with some of that stuff, but I can't guarantee it's all going to be in there, right? There's no way I could compete with something like Unreal. Oh, you're 38 in 2 months. When wisdom comes with age. Nice. Yeah, so you're up there with me, basically. Step 1, get a graphics programming team. Yeah, exactly, right? If only. If it wasn't just me, then yeah, it might be possible, but I'm just one dude. We're going to have ads here in just a second. So I think what I'm going to do is I'm going to start actually debugging through this. So let's go to standard UI render graph. And we'll do frame prepare first, and then we'll also do execute frame, just so that we can kind of get an idea of what the heck is going on. So this should always run, no matter what. It looks like it is. So current viewports. Oh, I think yep, I actually just figured out the issue. Passing the wrong viewport. What does this say? Perspective. We're using the wrong viewport. That's the entire issue. We're using a perspective projection matrix to render a UI, which is wrong. Okay, well, that didn't take long. was going to say, I'm not getting any errors. I must have just done something stupid, and I did something stupid. So for this, the camera doesn't necessarily matter, but ads do. And we are going to break for them. So for those of you who are new to the channel, or for you folks over there on the YouTube side, we are fed ads once every 30 minutes on the Twitch side for 90 seconds. So we like to pause the stream so that nobody misses any content while ads are running. So depending on region or locale, sometimes you get the full 90 seconds of ads. Sometimes you only get 30 seconds. Sometimes you get like a banner ad, or sometimes you get nothing at all. Depends on all those things. Region, locale, platform, things like that. So it varies, but I like to cover all of our bases, and let's just say we pause the stream while ads are running over on the Twitch side. I know the YouTube side works a little bit differently, but yeah, that's basically what we're doing, right? So we've got about 30 seconds left, and I'm going to also use this opportunity to, hydrate. You guys should do it too. David over on the YouTube side, hello, welcome. Hope you're doing all right. What are you up to tonight? Got about 10 seconds left on ads. All right, ads are dead. Cool. Turbo, yes. Yeah, I actually do have Twitch Turbo. Just because I got tired of seeing ads all the time. And the great thing is about that, and a lot of people don't realize this, is if you have Twitch Turbo, even though you're not subscribed to the channel, the streamer actually gets ad revenue as if you had watched the ads anyways, which is pretty cool. They don't really advertise Turbo. I don't know why they don't. Like it's a little tiny button up in the corner and it's gray. That says, Turbo or whatever. I don't know why they don't advertise it, but yeah. Nice segue. Yeah. I've been working on my segues into ads, right? So I'm glad you appreciated that one. Oh, you're LSR 108 on Twitch, but you're on YouTube today. Well, hello, LSR. Good to see you. I'll try to keep that in mind. I can't guarantee it, but I'll try. So I just noticed you're using Wes's terminal emulator. How is it? It's awesome. I love it. It's my favorite one out there. I use it across platform. I use it on Windows, Linux, and Mac. It's a fantastic terminal. You're currently using Tabby. It's nice, but man, does it take up a lot of resources. Yeah, WesTerm really doesn't. And it's GPU accelerated too, so it's fast. They probably lose money on Turbo. Yeah, I wouldn't be surprised. I mean, Twitch loses money on almost everything, right? They're not a profitable business still. They're trying to get to the point where they're at least breaking even, but they're not yet. They still rely on Amazon for all that stuff, right? Okay, so if we take a look at our standard UI, what it really needs is the current viewport, and it obtains the projection from there. We don't have to pass a camera at all because it doesn't use a camera. So this really should just be changing a couple parameters, right? So instead of world camera, we're just going to pass null. And instead of world viewport, we're going to do UI viewport. That should actually fix it. They don't seem very well run for the service they provide, plus the AWS discount they get on everything. So they've actually made a lot of really good changes lately in terms of streaming. Dan Clancy, who is the guy who is the CEO of Twitch, he's done a lot of sort of eating your own dog food and learning it. He actually streams on Twitch himself, and he didn't use anything within Twitch to like gather more followers or anything like that. He did it the hard way. just to kind of understand what it's like actually streaming on the platform. And that was actually, him doing that was actually one of the reasons that we're able to simulcast on YouTube and Twitch right now, because that didn't used to be a thing, and he actually made that a thing. Yeah, Thor's video on how much it costs Twitch to run a stream is fascinating, for sure. But yeah, he's actually been doing a lot of really overly positive things for the platform. So it's actually kind of turning around and becoming better. It's also, they don't get an AWS discount. They pay the same rate as everybody else, which sounds insane, but yeah, they've come out and said, you know, they don't get a discount on what is it, Amazon IVS, which is essentially what Twitch runs on. Yeah, they don't get a discount at all. They pay the same rate as everybody else. Yeah, it's kind of nuts. You use URVXT or XVT. Dyslexia got me again. I often have issues with things like Unicode support. Yeah, so WesTerm doesn't have those issues. Yeah, WesTerm has been really good about that, actually. All right, so get rid of the breakpoints. I don't think I'm going to need this one either. I think it's going to work. Yeah, it works. It works. It does the thing, right? So let's load up the scene. All right, cool. We are back up and running, right? We are doing the thing. It works. So we've just kind of done some refactoring right there. We're back to square one, more or less, right? The only thing that we have to do is fix this. On shutdown, we're not destroying the render graphs, so we need to do that. Which actually we could just do. I'm going to take this function and just make a copy of it, because it's almost going to be the same thing. All right, so instead of execute render graphs, we're going to do destroy render graphs. So this is going to be destroy. Okay. We don't need the p frame data. Right. Destroy frame. Destroy frame. Invalid argument type void. What? Did I do something stupid here? Oh. Because this is... Yeah, destroy returns type void. So there is no failure case for this one. Right, so we can just eliminate that. Right, and we can do rid of that, rid of that. Rid of that. Which actually, we should just convert this to void, since there's no failure case. Right, take this, go to the top, slam that right about there, and then great render graphs. Where's I think it's going to be an application shutdown is where we're actually going to want to do this. Yes. So we're destroying these manually here. We're not going to do this. We're going to do, let me clear the highlights. We are going to do destroy render graphs, and we're going to pass game instance. Let's see. I always figured Amazon and Microsoft own places and got a discount on cloud services. So it depends, right? Because, well, I don't know what Microsoft does, but I know at least in Twitch's case, they don't get a discount. You spent a lot of time on the refactor tractor. Hopefully it's almost time to park it. Yeah, I keep actually saying refactor tractor in my Twitch thing, but we've actually added some new stuff. So what we're probably going to do next, there's a few things I want to tackle. I do want to go ahead and move, I want to move our vertex and index buffer to be scene specific and then have one for the UI as well. So I want to do that. That doesn't necessarily have to be done right away though, just before we have another release. And then we do need to add some other stuff like being able to control the directional light. And then also like a sky sphere with like day-night settings would be really cool. I'd like to get that put in just because that's kind of a nice looking thing to be able to put in there. We do need to also implement, I think, probably at least a basic water plane, right? To just get some sort of, ability to have water in place. It may not wind up being anything fancy, but at least that way we've got some way of representing water in the engine. And we'll probably add a few different versions of that eventually. Let me just make sure that all of this stuff works as expected. Real quick. So I think our editor pass should still work. We can still select objects, move them around. That's good. And then when we unload, we're good. We're golden. Refactor done. Let's see. Will this engine support ray tracing, path tracing? I'd like to experiment with those things eventually. So that was one of the reasons that I did with what I did tonight. And technically we started last night, is to split off this sort of pipeline from everything else, is because I do want to support multiple modes of rendering. Deferred rendering is one of those things that we're not going to be able to avoid for very much longer. So I want to get deferred rendering in there. I want to get eventually forward plus. That may or may not happen before the first game is released. And then obviously we do want to play around with ray tracing, right? Like ray trace shadows, ray trace reflections, those kind of things. But obviously we need the baseline features in place before we can do the ray tracing versions of those. RTX on, yeah, exactly. So, yeah, some of those some of those things we're not going to touch until we actually have the base version of it in. Like shadows, we have the base version of it kind of in. We also need to implement point light shadows. We probably need to do that sooner rather than later too. Because if we run this, you'll note that they're missing, right? We have a red light that's like right around here, right? But notice that this tree doesn't cast any shadows from it, right? There's no shadows like cast from it at all. So we do need to get that in. We also need to get some better representation of lights in general, because right now they're just kind of these boxes that exist. Actually, I don't even know where the red one is. It's in the tree, right? So these boxes kind of tell us like the center position of the light, but they don't really tell us the radius and things like that. So we kind of need to get that in there too. We also need to implement things like billboards so that we can actually like maybe put some grass in, things like that. So yeah, we have lots of features we need to get in. But with all that said, I'm going to declare this branch done. So, iPure Gamer, thank you for the follow. Welcome. So let's see. We actually have... Where did I put that? So we have our forward rendering here, specialized render graph. That is a thing. It is done. We also, like, I was thinking about jumping onto this sometime soon too. And multi-threading like some of our loading stuff, like our terrain material for one thing. There's always more to do with graphics programmings. I've always felt so intimidated with it. Yeah, I mean, it's just, that's why we maintain this list, right? Because it's always satisfying to be able to put an X on something saying, this is done, right? So that's why we keep the list. And every time I think of something, I add it to this list. That's what you've helped me with the most. Just seeing one person do it has made it easier to understand. Good, I'm glad. I'm glad it's helped that way. That's kind of the goal, right? It is possible to do it on your own, right? And I'm trying to show that, but there are many caveats to doing it that way, right? Like everything else in software development, there's trade-offs. All right, so these are the things that we have modified. Oh, you know what? I didn't do the changelog yet. Let's do the changelog. Look at how much stuff we already have, by the way, in version 0.6. We've added all this stuff already in 0.6. And this includes like bug fixes and stuff as well. But created specialized, if I could spell it, specialized. Yeah, spelled right. Okay. Render graphs for forward rendering. One for the editor. Currently lives in testbed. And one for standard UI. All right. Okay. So with that, in the base folder. Okay. So get status. Let's just do this one more time. Okay. We should be good to go. So forward render graph. And what we'll do is we'll open up a pull request on the repo. Even though it's just me managing it, I like to do it this way because there's a little bit of history that way, right? Let me pull this down here. So we're going not into main, but into 0.6. All right. See, we added some stuff in here, actually. Let's see. Render graph. Let's see. Oh, this is the new forward render graph. Okay. So this is all kind of stuff we've seen before. I did get rid of these, but I left them commented in there. I'm going to leave it that way for now. We're going to handle debug geometry differently. So I want to leave these examples in there, but we're eventually going to be removing all of that stuff out of like our test bed and otherwise. Okay, so these are the new. So let's see, editor pass. We just moved that. Same with the scene pass. All this stuff has just been moved. Simple scene loader was moved along with simple scene. Oh, that's right. I wanted to rename that. You know what? I'm going to do that as a separate change set. Because that's kind of a big one. And I don't want that to interfere with this. Let me just check this real quick, make sure I didn't do anything dumb. Look at how much code we were able to delete, though, out of the application. All this. A lot of dead code, too. Okay. I'm satisfied with that. So from feature branch into 0.6, we will squash and merge and delete the branch. Okay, so that is done. Check out version 0.60, get to pull. All right. So that's all in 0.6 now. So now it's more of an object of just picking something off of our to-do list next. Something that we can reasonably get started on tonight. Deferred and forward plus, definitely not on those things. Forward plus actually requires compute shader support, so we don't have that yet. That is something I'm going to have to also add soon. This is also something I'm wanting to add. Batch rendering. We need to get that in there sooner rather than later as well. Compute shaders are when things get really fun. Yeah, exactly. And we might even be able to leverage those, for a lot of our geometry tasks too. A lot of the things that we're doing on CPU, we can offload to the GPU that way. We'll get there. One thing that I was thinking about was maybe we could start tackling this. Or at the very least, this. So thread pools are something that we could use to essentially fire off a whole bunch of threads of work and then wait on all of those threads of work to come back together to complete whatever it is that they need to complete. And then once all of them are complete, we move on. And the thing that I'm thinking this would be useful for is when we're loading that layered terrain texture. Because right now we're basically doing that inline one after another, and it takes forever. You'll notice when we load up the actual texture, the terrain loads, but the texture takes forever, right? And that's one of the reasons why. So I suppose we could start on that. Could that not be just a bunch of jobs? It could be, but the problem that we have with the job system currently, and that's why I was saying it should be like job dependencies is the other thing. It kind of goes hand in hand with thread pools, because the job system essentially has kind of its own thread pool that's built in. And for this job dependencies / this last bit here, we would probably want to refactor the job system to use these thread pools instead. So we don't have the ability to say, fire off all these jobs, wait till they complete, and then fire off another one. We don't have job dependencies, right? And so I'm thinking the best way to actually get that functionality is probably with doing this first. We could try it without it. But we do need job dependencies. That's been something that's kind of been floating around there for a while. So basically, I would have to sit there and pull, essentially on an update loop or something gross like that, and wait for all the jobs to be complete that way before I could actually upload that data to the GPU. Yeah, job dependencies I'm thinking is probably what I need to do. So let's take a look at that. So here's the job system. Oops. So in fact, I'm I'm going to close that because we don't need it right now. So right now we have just a couple of different types of jobs, right? And the reason that this matters is because it decides potentially what thread the job actually runs on. So general is basically just a general purpose job. It doesn't matter what thread it runs on. A resource loading job, we could potentially group those by thread if we wanted to, but again, it doesn't really matter all that much. What really matters is GPU resource, and we're not using this one yet, but when we have multi-threading in our renderer, we're going to have to dedicate a certain job thread to only do GPU tasks, because the Vulkan resources that are created have to be created in the thread they're going to be used on in that case. And so we basically have to stand up a job thread that stays alive, which they all currently do, but is specific for GPU uploading jobs, right? And so that's what that's for. We're not using it yet, but that's one of the things I want to start working towards as well. So we have those three. We have job priorities. So the default is normal priority. And so this is kind of like what gets used for, well, as it says here, like loading assets, right, off disk. We have a low priority job, which basically runs only when there's no normal or high priorities to be run. And then high priority basically runs immediately. So low and normal get run at a minimum on the next update pass, but could potentially wait longer than that. Low is basically prioritized below everything else. But a high priority job gets created and kicked off as soon as it's called, right? So that's the difference there. And then as far as our job info, we have the type, the priority, function pointers for the entry point, the success, and the fail, and then parameter data and a size for that, right? That's typically dynamically allocated. The job system actually takes a copy of that data internally, and then the same is true for result data. And then the job system config, that's how many threads we want to use. And then what types of type masks for each job thread, right? So if we have 8 threads, we actually assign the type masks for each thread. And that's how we determine that. So those are bitwise combinations of these guys up here, right? So there's that. So initialize, shutdown, that's all pretty self-explanatory. We've all seen that stuff before. This is probably where it's going to change, right? So we have job system submit, which just takes job info. Here is a job create. This is basically just a convenience function to create the job info struct. So just creates and returns one of those based on the parameters, right? So we did that just so that you have like a convenient thing here with documentation as to how it runs. And then we also have the ability to create a job of a certain type, right? So it's just the same as above. We just specify the job type there. And then we have create priority, which we specify job type and priority at the bottom, right? So what I'm thinking is more than likely in the job info itself, we would probably need to have some sort of reference to a job, right? But the thing is the jobs themselves aren't actually exposed. Like we have this job info, which is sort of a configuration for the job, but the jobs themselves aren't exposed, right? That's an internal structure, and I want to keep it that way. However, our job system submit is currently returning void. And so what I'm actually thinking is we might actually leverage this and change this type to return like a U64 or something with a unique job ID. And every time we kick off a job or we submit the job, we get a job ID back. And in the job info of a job that depends on it, we would then add that job ID to a list of things that have to be done. And I'm thinking a job ID would probably only ever be used once. And you could essentially query the job system as to whether a job of a given ID has been completed. And speaking of jobs, our next job is ads. So we'll go ahead and wait for the ads to roll through. So, and I do see your comment over there on the YouTube side of things. I will answer that when we come back from ads, but I do see that. So we are served ads once every, where's my water bottle? We're served ads once every 30 minutes for 90 seconds on Twitch. And I just like to pause the stream during that. So feel free to go ahead and hydrate. We've got about 50 seconds left. If you haven't already, go get some water, right? And I'm just going to give myself my voice a rest for a second. We've got about 30 seconds left on ads. Almost there. On fire tonight with the segues. I'm glad you appreciate it. All right. Cool. Ads are dead. All right. So there's a question over on YouTube about the versioning and the branches. So let me just touch on that really quickly. Do I still have Paint open? I don't. So basically the way that, and I'm going to make this really quick, okay? But basically the way that our versioning works is we have, I'm going to do this horizontally, I think, because it makes a little bit more sense. Let me actually maximize this, give myself a little bit more room here. Okay. So basically the way this works is we have, excuse the non-straight line, we have our main branch. That's a terrible M. Let me try that again. We have our main branch of code, right? And up till now, we've just sort of been, checking in changes along the way into the main branch, right? Or sometimes we would, sort of make a feature branch, do some changes, and then go back into the main branch, right? We've adjusted the way that we do that. And the way that we do that now is we now have version branches. So we started this with 0.5, right? So we branch off and we create this 0.5, right? And from there, we create feature branches off of that, do the thing, go back into 0.5. Create our next feature branch, do the thing, go back into 0.5. And then, we do this several times until we're done with features. And then we take 0.5, we merge it back into main, and at that point we tag it as a 0.5 release, right? So there's a 0.5 tag, right? And then at that point, we move on to the next version, which in this case is 0.6, right? So we're kind of looking a little bit like this right now, right? And we've had some feature branches that we've merged back in, or whatever, right? And then eventually, when we merge this guy back in, we'll tag it, and then we'll move on to, the next one, the next version, and so forth. And that's kind of the way that we're managing that, right? So I hope that makes sense. Okay. So, what I'm thinking with the job submission is we have a job ID that's numeric. It'll be unique. We'll just kind of keep like an internal count of of jobs. Every time we kick off a job, we will store off that ID, and then we'll flip an internal flag, I guess, when that is actually changed, right? So my thought here is that maybe we do this. We say U64, and then here we have return the job ID, right? And well, there's actually a problem with this. There is a problem with this though, because when we submit the job, depending on priority, it could start right then and there. Before we even create the next job, it could start, right? Which is not necessarily the greatest thing. So maybe the problem is like the job could be submitted, and since it's on a separate thread, it could technically complete before we even start watching for it, right? Which we could just check and ask the job system, is this done? But again, that requires polling, right? Which we might have to do anyway. I guess we could also... We really should probably be using like a semaphore or something internally for that instead. So we're going to have to think about this a little bit, right? Because I want to avoid race conditions with this, obviously. So maybe we change... You know what? Let's not do that there. Let's do that in job create. So when we call job create, it's going to fill out in the job info the ID at that point, because it won't have been submitted for execution, right? It will have just been assigned a job ID. And so you could basically queue up a whole bunch of jobs. And then you'll have the IDs for them as soon as you create them. Yeah, let's do it that way. All right, so let's go to job system C. All right, and job system state. Let's see, we have... I guess I could put this up here. So we'll do a U64. Current job ID. And we'll also need a way of tracking when jobs are done. And the simplest way that I can think of this is essentially an array of bools, right? Which unfortunately is kind of wasteful. Let me think. Because we need to be able to query whether a job has been completed or not. So we've got to maintain that state somehow. Unfortunately, Booleans are like super wasteful, right? Because you really only need one bit and it's a full byte of data. I suppose we could like split them into You know what? I'm going to do this simple first, and we'll worry about optimization later, right? In fact, I'm not going to do a U64 on this. I'm going to do a U32. And I think if we ever hit the upper limit on job IDs on this, we'll just throw an error so that we know. But really, we should probably just loop back around and clear the list whenever that happens. thinking. So if we do a B8 array of job statuses, and I'm going to put a to-do here. This is a massive waste of memory. Combine 8, 8. At a time. Into each bool. But I'm not going to do that right now because it'll be much simpler for us to just index into this. So we'll have a current job ID that'll get incremented. We'll have job statuses, which are essentially just 1 or 0. And what we'll do is we'll index into this array using the job ID. And then that's how we'll query. It's nice and simple, but it'll provide an interface that we could change later to maybe optimize it for memory. Multi-threading is something I don't have much experience with. My last serious programming job 10 years ago didn't use it. Yeah, it can get hairy really quickly if you're not careful, right? You'll notice we have mutexes in here and stuff, right? Catme, hello, welcome back. All right, so store result, I don't need to do anything with that. Job thread run. Let's come back to that. Let's actually go to the bottom. And so if we look at this, these job create functions all just pass through to job create priority, right? Using some defaults. So that way we only have one path of code. So this does not use... Oh, okay, we do have it statically available. Okay. All right, so I'm going to need the system state for this. Let's see, we have a mutex per job thread. And then the job system state, we have a mutex for each priority queue. And then one for the pending results array. All of those things should be called from the main thread, though. Not necessarily. Technically speaking, these could be called from another thread. And if they are called from another thread, we could have a race condition from that. So we probably should be safe and wrap that in a mutex. Okay. So we'll say job status mutex. I'll create another one. Job system initialize. Here we go. So this is where we stand up all of our mutexes right here. So I'm going to do one more. And this is bothering me that I have an exclamation point and a period in here, so I'm going to delete these. It's probably a copy-paste error. All right. Failed to create. This is going to be failed to create job status mutex. There we go. All right, so we create the mutex there, which obviously means that we have to destroy it. All right, so we've got that. Now we can come down here and we will kmutex lock, take the address of state pointer job status mutex. I forget, does this return an error code? Returns Boolean. Okay, so we need to check that. If that for some reason fails. Failed to lock job status mutex. All right, not really much we can do about it, but we are at least going to bleat about it so that we see it. So between that, we'll do a, let's see, we probably ought to, we'll say job dot, oh, we don't have a thing in there added for that yet. So let's do peak definition. We have job type U32 ID. The unique identifier of this job. All right, so we'll say job.id equals state pointer job current job ID. So we'll take the current ID, then we'll do state pointer current job ID, increment it. We'll do state pointer job statuses job.id equals false, right? It's false for not complete. And then we'll do k mutex unlock address of state pointer job status mutex. Does this return a Boolean? I think it does. Yep. So if that fails, failed to unlock job status mutex. All right, and again, there's not much we can do about it. And I'm gonna leave a note here to my future self. Technically, jobs can be created in the middle of other jobs, i.e. on a different thread. So make sure to lock around these updates. Okay. So now when we create a job, we've got a thread-safe way of getting a job ID, a unique job ID, incrementing our internal counter, setting the status of that. And now when we go to complete that job, we are going to need a way to actually set that. So let's see, where was that? I think it's in the thread run. Process queue, that's not it. It's probably towards the top if I had to guess. Yeah, here we go, job thread run. So this is the runner for each individual thread. So we take a copy of the job info. We do the entry point bit. And this is what gives us the result. So at this point, we store the results. We free the param data. We lock and reset the thread's info object. Okay. So at this point, this is where we're going to want to do that update. So update the job status for this job. And actually, did we clear out the info already? Param data thread info. Okay, we have to actually do it before this. We can't clear the info until we actually have, until we've updated this. So we actually have to do this here. Right? Okay, so we don't have to do this. This is going to be, instead of job ID, it's going to be thread info.id. And we're going to flip that to true. New Brew, thank you for the follow. I appreciate that. Max Dignitas, what up, nerds? No truer words have ever been spoken, my friend. We are all gigantic nerds if we're into this stuff, right? Okay, so we lock the job status mutex, we update the status for that job, then we unlock it, and then we update that thread's info. All right, cool. So the last piece of this is going to be our query, which I guess we can just put towards the bottom. So let's call this, we'll have a return type of B8, and we'll say job system query job complete. And we'll do a U32 job ID. I'll put this here. And what we'll do is we'll have a U32 ID equals invalid ID. We'll just kind of default that, right? And then we'll need to lock that again, because again, we could be querying from another thread. And then here we'll do or no, I don't want ID. I want status, B8 status. So we'll do status equals job status is sub job ID. Right. What the heck? Status is, there we go. Wait, status. There we go. Okay, so we lock, set the status, unlock, return status. All right. So we need to take this and put it on the header file. So let's do this. We'll export that with KAPI. And let's move this up a little bit. All right. So brief returns whether or not the job with the given identifier has completed. Good enough. There is one bit that I forgot to do. An important bit. I didn't allocate that memory. So let's see. Job system initialize. Okay, so we need to just build this into our memory requirement and we'll be good. So let's see. How many, what do we want our max number to be? of job IDs. I guess it could be like max U32 minus 1, right? Which would technically be invalid ID is what that is. What did we say for max job results? 512 isn't nearly enough. Okay. So let's add to this size of U8 times invalid ID. Which I know sounds weird, but that's our invalid ID, right? That's going to be a huge array of memory. And this is why I'm saying it's a massive waste of memory, right? Technically, it needs to be invalid ID minus 1. That's way too much. I need to cut that in like a very small number. This is the only thing that sucks about tracking state, right? But if we want it queryable, we have to. But that's like, yeah, we can't do that. That's 4 gigs of memory, right? So we might actually have to pack these into U8s, which will mean that we can't cleanly index. So what if we do divided by, well, actually, what if we just do if we do this divided by 8, right? If we do that divided by 8, and we pack the bits tightly, then we should be good. That's what we're going to have to do, because otherwise it's just going to take entirely too much memory. I mean, let me think about something here. So we do we basically would wind up with that. Oh, I typed that wrong, but we basically wind up with something like that, right? Which is basically like 53 megs, right? 54 megs, somewhere around there. Which is a lot for just the job system. Even that seems like a lot. I wonder if we should just limit this to U16. I think that's what I'm going to do. Let's do this. We'll still say minus 1. And so we take state pointer, job statuses equals state pointer as a U64. Oops. Plus size of U8 times invalid ID 16 minus 1. Oh wait, no, that's the whole size. Actually, I just want size of job system state. Right. And then oh, we have ads. No fancy segue that time, Taman. Okay. I'll go over that when we get back from the ad break. Let's see. So Max, I do see your question there. I'll answer that as soon as the ad break is over, right? Because I don't want the Twitch folks to miss that, right? So we're just gonna take we got about 50 seconds left. I'm gonna take this moment to just hydrate. And then I'll answer your question there. Thinking I should probably put like a visual timer on this screen so that you guys can see how long we've got left. That might be a good idea. Wonder how much of a pain it is to do that in OBS. I'll have to look. Okay. Almost there. Cool. All right. Ads are dead. All right. So the question is this our render graph scheduler? So kind of. It will be eventually. So what we're doing right now is we're enhancing our job system to support job dependencies. And the first step of that is to assign a unique identifier to each job and then track the state of each job by that identifier to see whether or not it's complete. That way we can actually query the system and say, hey, has this job completed yet? And then we're also going to take a look at maybe using semaphores or something like that to signal job completion instead of the wait that we're doing in the loop, right? And so, we're going to enhance this and make it a little bit more robust through that. So we're kind of doing the first step of that now. I highly doubt we're going to finish that tonight because it's already after 10:30. So, okay. So what we've done here is we basically just upped the job system memory requirement by the size of our status array, which is going to be an array of U8s that is of up to the max U16 minus 1. And so we actually just need to fix a couple of small things, like job info. We had the ID as a U32. I'm going to switch that to U16. Just because it's going to take way too much memory otherwise. I don't want to reserve 4 gigs of memory for this. And obviously I could pack the booleans, but I'm trying to keep this as simple as possible for now. So this is going to be U16, which means the conflicting types. Okay, so job system H needs to be U16, right? So we've got that. I don't know if there was anywhere else. So we have this current job ID that gets incremented, which is going to wrap around, right? We are going to have lots of jobs that run. So eventually that is going to wrap around. So I think what I'm going to do right now is I'm going to put do we not have I guess I didn't include that. Let's include our assertions. We're going to say kassert. Actually, let's use a message for that. So the expression is going to be state pointer current job ID is less than invalid ID U16. And if it's not, we're going to say job system identifier overflow need to pack booleans. All right. Pack booleans. All right, so at least we catch it. If that ever happens, we'll see if it does. That means we have to run 65,000 jobs before it actually happens, right? So theoretically, for a long-running application, that'll eventually happen, right? But if we pack the booleans, we'll get 8 times that much storage, right? So this is a way that I can sort of mark it as a to-do, but safely ignore it for now until it becomes a problem, and then I'll just refactor it at that point. Okay. Current job ID, I think, is also, yeah, that needs to be changed to a U16. Job statuses. It's an array of booleans, that should be fine. Job ID should also be a U16. Yes, it is. Okay, so I think I've covered the bases on that. Okay, so the second part of this is going to be job info. So we have an ID. We also need dependency IDs. So I'm trying to think of what the best way is to do this. Probably it's going to be adding another function to the bottom where we can specify that. And then just passing defaults all the way through. So I'm thinking U32 dependency count and U16 array. Honestly, this could just be a U8. Can't see us having over 200 job dependencies, right? That's ridiculous. Dependency IDs. Okay, so this is going to be an array of job identifiers that must be complete before this job starts. Right? And then actually this comment's going to be mostly the same, so we'll say a count of job identifiers that must be complete before this job starts. Okay. And then at the bottom, we'll add another function. Create job priority. Let's see, type. So I think if we're at the point where we're specifying dependencies, we're probably going to want to specify all this stuff anyways. So I think I'm just going to do something similar here. Right, but we're going to call this one with create with dependencies, right? So this creates the job with the provided type, priority, and dependencies. Right, and then we'll just add 2 more parameters here to the end. I'm going to multi-line this one because this is too long. Try that again. Okay. Okay, so we got job type, job priority. And then to that, we will add U8 dependency count and a U16 array dependencies. So here, dependency counts, the number of job identifiers which must be complete before this job runs. And dependencies, an array of that. Okay. So we've got that. Take this into the C file. And let's put this here. All right, and I'm going to take all of this and put it in here. And then we're going to essentially do job create with dependencies, entry points. I'll just pass all of these through. Right, and dependency count is going to be 0, and dependencies is going to be 0. And we're going to return that. Right? So ultimately, they all pass down to this function. This function is the one that does all the work. Now, here at the bottom, we will say job.dependency count equals dependency count. And then job, actually we'll say if dependency count job dot dependencies, dependency IDs, is equal to k allocates size of U16 times dependency count. And then that's going to be a memory tag array. Otherwise, job.dependency IDs is null. So we've allocated this. We also need to take a copy of that. So now we can say k copy memory. Destination is going to be job dependency IDs. This source is going to be dependencies. And the size is going to be this. Right? So we'll take a copy of that. That way we don't have to worry about the life cycle of this dependencies array. Okay. So we have that. Let's see. Lisp Gamer, hello. Are you building a system to handle dependency resolution between task jobs? Yes. Yep. Is all of this threaded? Yep. It is. Indeed. It is indeed. So I forgot to answer this, or I think I forgot to answer this, Max, but you were asking if this is a render graph scheduler. It eventually will be. I'm not sure if I answered that eventually or not, but yeah, it eventually will be used for that. But for right now, we're just basically setting this up so that we can have either jobs that run other jobs, or so that we can queue up a whole bunch of jobs, kick them all off, and then wait until all of those jobs are done before doing something else, right? But yes, it is dependency resolution between tasks/jobs. That's ultimately what we're doing. Okay. So we have the dependency counts. This is job creates. So when we are finished with the job, we are going to need to free that memory. Let's see. When would be the best place to do that? Probably in here. Info mutex. No, that's process queue. That's not where I want to go. It's going to be here. So here's where we actually kill the threads job info. So this is actually where we want to be. So k-free. Actually, we need to check first. So if thread info dependency IDs k-free thread info dependency IDs size of u16 times thread info dependency count. The tag is memory tag array. So we free that, and then we also do thread info dependency count equals 0, which I guess we don't really have to do that because we zero the memory here. In fact, I'm not going to bother with that. It gets zeroed out right after that. So we free this array if it exists, and then we zero the memory after that. Okay. So we have that. We have a way to query it. The only other thing that we need to do is, as we are looking through the queue, we need to have a look at the dependencies and make sure that all the dependencies of a job are resolved before we actually try to kick off the job. So that's the next bit. So that's going to be on job thread run. All right. Actually, is that going to be here? No, it's not going to be on this thread. It's going to be in process queue. So let's see. We have job info. Okay. So before we actually search for a thread for the job to kick off on, this is where we should do our query to see if the dependencies are actually resolved. So check that, actually I should say verify dependencies are complete. So in this case, if info dependency counts, then we have to do this check, right? And we'll do for u32i equals 0, I is less than info dependency counts plus plus I. And then we can do job system query job complete, and we'll do info dependency IDs sub I, and then if that's not complete, then let's just do a trace for now. Note not starting job ID because its dependency job ID is still running. So we'll do info ID and info dependency IDs sub I. And then we will do continue. Wait, shoot. That's going to continue the for loop, not the while. Okay, so let's do B8 awaiting dependency equals false. And then we'll do awaiting dependency equals true, break, and then down here, if awaiting dependency, continue. Okay, so that should cover us. That should keep us from running jobs that have dependencies that are still currently running. I think that's it. I'm trying to think if there's anything else. So I guess, let me build first. The very first thing we're going to want to check is to make sure that we didn't build or break the, the current jobs that are out there. Okay, well, it built. So that's good. Let's try running it and see what we get. All right. And we'll load. And what do you know? We didn't break it. So that's pretty cool. Like that. Okay. Which makes sense. We shouldn't have broken it, right? So the next step of this is going to be putting this to use, which the first place we're going to use that is in our terrain. Let's see, do I really want to start that tonight? I'm going to take a very, very fast stab at it, and if it doesn't work in a couple minutes, I'm going to dip out, I think. Because it's getting late. Thank you for the happy affiliate anniversary, by the way, Catme. Appreciate that. Or is that Cat MLE? Have I been reading that wrong the entire time? Probably. Cat MLE. Yep, okay. Dyslexia's hit me hardcore today, man. Let me tell you. Tammin with a 5-stream streak. Appreciate that. Appreciate that a lot. Oh, by the way, Tammin, I have some ideas for point redeems. I'm not ready to go public with them, but I have some ideas. Incidentally, on that topic, if you have any ideas for point redeems, hit me up on the Discord server and let me know what they are. But I've got some ideas that I'm trying to figure out how I'm gonna put them together and make them work. But yeah, I have some stuff in mind because I know you have a lot of points. Oh, Spiro, you've been lurking. Awesome. Thanks, man. I appreciate that. I appreciate you being in here. You have 34K coffees. Yeah, I'm going to have to come up with that quick. Maybe Spiro's got an idea for me or two of redeems. But, you know what? I think I'm going to call this for tonight. Because I am going to try and stream maybe tomorrow. We'll see. Or maybe sometime this weekend. I don't know yet. But we're going to use this to make our terrain loading a lot faster. But for right now, I think that is going to do it for tonight. So let me actually cut a new branch. So we'll call this feature job dependencies. Get status. I think those are the only two files we changed, I think. Okay. Gets, commits, added job dependencies. Oh, you know what? I forgot to update the to-do. This, technically, is actually a done feature. We got that done tonight, which is pretty sweet. Added job IDs and job dependencies that can be used to link jobs one after another. All right. So we've got that. I'm just going to use the same commit message. It's fine. What do we call this? Job dependencies. All right, so you guys will have access to this code. It's up there on GitHub now. If you're interested in that, it's there. And then we will, on the next stream, we'll pick that up. Let me have a look and see who is online. Let's see. I'm going to go to the old browse page here for a second. Okay. I am going to raid Chris, or CM Griffing, because he is... Looks like he's working on Vexilla right now, which is his like feature flag system that he's been building for quite a while, and it's pretty freaking sweet. So definitely ask him about that. But he's a pretty cool dude. I like hanging out and interacting with him. He's a neat guy. So he definitely knows his stuff. So I'm going to toss him a raid because I haven't raided him in quite a while. So let's do that. Thank you guys very much for being here, joining me on the stream on either side. I really appreciate you guys being here. If you haven't already, toss me a follow on both places because it helps me out, grow the channel, all that good stuff. And I will see you guys next time I stream. So peace. See you guys on the flip side, right? All right, and there we go. All right, see you guys.